Hi everyone, welcome back to our channel. Today we are going to solve problem number 23. That is nothing but a series RL circuit is given excited with an AC supply having an resistance of 4 ohm and inductive reactance of J3 ohm is connected to an single phase 100 volts 50 hertz supply. Find the current. So we need to find out the current as well as the power as well as the power factor drawn by the network. So here let's try to see here. The quantity what is given in the problem is the RMS quantity. So we can write down the RMS quantity V is equal to 100 at an angle of 0 volts, and we require the impedance. So you can see this impedance. The impedance is nothing but R plus J XL ohms, where you can write down this as 4 plus J3 ohms. Use your calculator, convert this is in the form A plus IB, which is nothing but rectangular form. Use your calculator and convert into polar form. Then resultant answer is 5 at an angle of 36.86 ohms. Okay, therefore we want current I is equal to V by Z. V is equal to 100 at an angle of 0 divided by Z. How to write down the Z? So rather than write down in polar form, this is 5 at an angle of 36.86. Okay, 5 ones are 5 20s are, which is nothing but 20. This is positive. When it comes to the numerator, this is nothing but minus 36.86 degrees. This is the current value to what we are going to get. Okay, and from here we already find the current. We need to find the power. So power formula is equal to I square into R. The value of I is how much is 20 square into R. What is R given in the problem is 4, which is nothing but we are going to get 1600 watts, and we need to find the cos phi. So cos phi is the cause of angle between voltage and current. What is the angle between the voltage and current? This is 0, this is 36. Angle between voltage is 0 minus of, what is this angle here you have been obtained is minus, this is 36 we have been obtained. So and here the I we had obtained as minus, so minus of minus 36.86, so minus into minus will be plus. If you perform this, then you are going to get the lagging power factor. So power factor is the angle between either voltage or current, or directly you can write down the impedance. Why? Because impedance is the ratio of voltage by current, is indirectly also the same. So directly we can use cos of angle between the impedance offered is 36.86, or the difference between 0 minus of minus. Minus of minus is how much? Both. So this is how to obtain the power factor of the given problem. Okay, just you can use your calculator and just apply cos of 30 cos of 36.86. Okay, then you are going to get this value. So the value you are going to get in lagging, and the value you may get approximately some 0.8 lag. Okay, this is the power factor you are going to get. And now let's try to draw the phasor diagram where you can understand better. So voltage, we have to take the RMS quantity. This is maintaining a voltage of 100 volts at an angle 0, where there is nothing but the voltage. But when you see the current, magnitude is 20 and the phase angle is minus. Okay, so whenever we get minus, we have to come in counterclockwise direction, and let's try to draw the magnitude. This is the magnitude of I, which is of current I is equal to 20 at an angle of minus 36.86. This is of magnitude 20 and subtending an angle of minus 36.86. Okay, so I can say now voltage is first and current is lagging. I can say current lags, voltage leads by an angle of 36.86. That's how to draw the phasor diagram for voltages as well as the currents. And remember, while drawing the phasor diagram, we should consider only the RMS quantity. This is also RMS quantity, and this is also the RMS quantity. Okay. So this is how we find the current. This is the amount of current. This is the power drawn of 1600 is your answer, and the power factor is 0.8 lag, and this is the corresponding phasor diagram. If it is asked in the exam, you can draw the phasor diagram. Hope my explanation is clear. Please like the video and share with your friends those who are studying the same subjects. And still, if you have any doubts, let me know in the comment section. And if you're watching my channel for the first time, subscribe to my channel with the name KB Tulasiram. Okay, so kindly support this sort of free channels for the development of students as well as for the faculty. Thank you for listening patiently. We'll meet in another video. Yours Ram.